Hello, I'm back again. So we're doing a little bit of a little more on this. So we did this Advil problem in class, and then we kind of went with it from there. But we didn't finish this problem, and I would really like to almost go through it again to help reinforce what we did in class to help you better understand what we're doing here. So okay, so we have 800 milligrams of ibuprofen in an Advil dosage, and the body metabolizes the medication at a rate of 18% per hour. Is it linear or exponential? You all, I believe, yelled and said it is exponential. And because it is a constant percentage of increase, it is exponential. Whoops, I didn't mean to cross it off. It is a constant percentage of, actually, this case, decrease. That's what makes it exponential. It's a constant percentage of increase or decrease. What's the initial amount? And I believe you all said 800 milligrams. What percentage leaves the body? 18%. That means 82% is left over. Is this an example of growth or decay? You guys all said decay because it's leaving the body. And I asked you to write the function that represents the situation. So now that we know that it is an exponential function, again, your model is going to be y equals ab to the x power. Do you remember what a was? If you said initial amount, very proud of you, initial amount of whatever it is, okay, it could be anything. And then your B is the percent you are increasing or decreasing, yes? How about your percentage of growth? How about this? I want to say that. Your percentage of growth or decay. All right, so here I am just writing all over this thing. So if we are decaying, right, and I want to find out what B is, if you remember what I said in the other video, if you actually watched it, if 18% is leaving your body, when you first take that Advil, that 800 milligrams represents 100%. Yes, that's 100%. So if you're taking 100% and it's metabolizing at a rate of 18%, it leaves you with 82%. So that tells you that your B is going to be equal to 0.82. Now remember what I said. If you are decaying, that means then, that tells you that B has to be less than 1. If you are decaying, B has to be less than 1. If you're growing, B should be greater than 1. And if B equals 1, it's not doing it, it's not growing at all. Think about that, right? If you multiply something by 1, it's not changing. So if I ask you to write the function that models the situation, you should be able to say, well, I hate that thing always comes up. Does that happen to you guys too? It happens to me. Anyway, so Y is equal to your initial amount, which is 800, times 0.82 to the x power. Now, usually when we have exponential growth problems, I'm just going to see if I can find a little bit of space. It's growing, which means it's always increasing. So if you wanted to model, if you wanted to guess what this would look like, if it's decreasing, that means your numbers start off bigger, but they start to get smaller. So if you want to sketch in your mind or on the paper what you think it would look like, hit pause and do that, okay? Okay. And what you should realize, it's going to be more like, it's going to be doing something more like that. So now it says to sketch the function on your GC. What was your window? Well, if x, tell me who is x, right? If we think about who x is and who y is, what does x represent? Well, x is equal to the number of hours, right? Is the number of hours. And y is equal to the number of milligrams left in your body, right? Milligrams of Advil left in your body, okay? I know I'm butchering this, but you can get over it. You know what I'm trying to say, left in your body. So your window, you're sketching this function on your graphing calculator. So when we're trying to figure out what the window is, I think what we should do is, I want to know, like, after a day, how much is still left. So that means that your domain would be from 0 to 24 hours, okay? So what we're going to do is we're going to go on off to that little graphing calculator of ours. So everybody get your calculators out. And we're going to go in here and we're going to clear this guy out and we're going to clear out this guy. So hit clear and we're going to put in up top, y is equal to 800 and then times 0.82 and then raised to the x power. And again, we're going to go into our window. And if you click onto window, I don't want 80 hours. I actually want 24 hours, right? So we'll go to 24 hours. And then we'll press our zoom 0 for our fit, just to get a nice little fit on our graph. And you can actually see that graph is actually decaying. So if you're looking at this, wow, it's just going down. So if I asked you, when is your body metabolizing this thing the fastest, where would you say along this curve? What do you say up here, along, where along here do you think it's metabolizing the fastest? And as time goes on, what's happening? Because let's just press the trace key. So if we press the trace key, whatever it says on yours, you should be able to interpret. Mine says that after 12 hours, because X is hours, Y represents the number of milligrams of Advil left in your body. So there is still 73.936 milligrams of Advil left in your body after 12 hours. So that's just an interesting thing to note. And if you hit your left and right arrow keys, you can go tab back and forth and you can basically see what's going on with your curve. Okay. So if we go back to this problem over here, state the domain and range. I think we answered that. The domain was the X was your number of hours. Your range was the number of milligrams left in your body. So if you think about it, you already know what the highest Y value is in this problem, even before you start. Why? Why do you know that? I hope you said because if you're starting off with 800 milligrams and it's getting smaller and smaller, hopefully you're hoping that it gets to 0, it'll do that. So here's what I want to show you. So we know if we go from 0 to 24 hours, if we put that in as our domain, then our range is going to be, oops, let me get this over here. Then my range is going to be, I know it's maxing out at 800. It's never going to go above 800. And here, I'm actually going to put here, it's never going to go below, I hope you said 0. Because what's interesting is go back to your graph. And let's just trace along here. Let's just trace. And as you do it, here's time just keeps going. And as you keep going, like here we are, we're past a day now, we're into day 2. And if you look, if you notice, like there's still 36 hours. Here we are, we're approaching 36 hours, and as we approach 2 days, it's almost 2 days later. And if you notice, we're getting closer and closer to, it's never going to get to 0. Now ask yourself, why is it never going to get to 0? It wants to approach, it's approaching 0, but how come it never gets there? Ask yourself why it never gets there. Press a little pause on that little thing, on this thing that I'm recording here, and ask yourself why it's doing that. If you said because you keep multiplying by 1%, you're always going to be reducing and reducing, but you're never going to get yourself to 0. You're going to get pretty darn too close, but you're never going to actually get there. Okay? So if you go into your window now, look at how it changed. Your X minimum is now at 17. I don't want it at 17. I don't want it there. We'll leave it like this, and let's do a 48-hour window. I kind of like 0 to 48, and then press your zoom 0, and let's see what that looks like. So again, it's showing you, wow. Okay, so if you look at this over the course of 2 days, look at how fast that's decreasing. It's so fast. And if I said to you, where does it look like it's decreasing the fastest? I hope you guys said it's almost like initially, and then over time, it starts to leave your body a little slower. It's taking a little more time to metabolize because there's less of it. So excellent point. All right. So let's go back to this guy right over here, and it says how much Advil is left in the body after 2 hours, 6 hours, 12 hours, 24 hours. So you can easily take 2 and plug it into your formula and then spew out the answer, or you could easily go into your calculator, and do your, again, second calculate and your value, and after 2 hours, you're right there. There's still 537.92 milligrams left in your body. If you wanted to do it again, well, let's do after 6 hours, so plus 1, and then put 6 in there, press enter. There's still 243.205 milligrams left in the body. So it's just a plug and chug, just calculate a value. Now, on the flip side of this, let me go back over here. On the flip side of this, it says, when will there be 385 milligrams left in the body? So up here, I gave you the time, and I wanted to find out how many milligrams there were. So I gave you the X, and I wanted you to find the Y. Now I'm giving you the Y, and I need you to find X. So from a graphical perspective, and when you want to use your graphing calculators to go ahead and do that, I want to know when Y is equal to 385 milligrams. So the best way to do that As I said earlier, if you watched the video earlier, if you didn't, that's okay. You go back into y equals, and this is our equation. Now you can plug and chug, you can guess numbers for x, you can plug in, any number you want to see how close you actually get to 385. That's fine. You're like, oh, I'll plug in 7. I'll plug in 8 for x and see how close it gets to me to that 385 milligrams. So you could totally guess and check. Or I'm asking you when y is equal to 385. So if I said to you y equals 385, from a graphical perspective, you knucklehead should be like, oh, Sichuan, that is a horizontal line. So now what we're going to do is we're going to graph 385, because that's asking you when does y equal 385. So now we are trying to find the point where the exponential function and that horizontal line intersect. So I'm going to do second calculate, and you'll see number 5 as an option, as an intersect. And then you're just going to scroll along this curve to get as close to that point of intersection. I'm hitting my left arrow. Okay, looks like it's pretty close. First curve, yeah, looks like a nice spot. Second curve, and then third curve. So you press enter 3 times, and then it'll give you the intersection. So it takes about 3.685 hours for the bodies to have 385 milligrams in there still. So if I told you that's how you would do it for 385 milligrams, how would you do it for 122? Please tell me. Again, I'm asking you when y is equal to 122. So we can go back to our calculator, and I'm just going to go to y3. I'll put it into y3. I have space for all of these things. Actually, I'm going to put it into y4 so I can see the pretty purple line. And I'm going to put in 122. I want to know when y is equal to 122. So when I press graph, it's the purple line now. So because it's the purple line now, I just want to do, let me see, second calculate, and then 5 intersection. And now the nice thing is, watch this, I'm going to show you something really cool. You're going to go up to where the intersection looks like it's going to be. Okay, you'll be able to tab there faster, and this is such a temperamental thing. If you press the left or the right arrow key too many times, it just keeps going past, and it drives me absolutely out of my mind. Okay, so you'll notice if you look up here, it tells you what equation you're on as far as the cursor, where this little tab is. So I'm going to press enter. Now you'll notice it just jumped up to the second curve. I don't want to find the intersection on the second curve. I want it on the third curve. So if I press my down arrow key, you notice what I did? So if I press up, it puts me there. But if I press my down arrow key, it actually puts me on the purple line. So it'll let you know. It'll say, oh, you want me to put the cursor on Y4? Yes, I do. Press enter, press enter. And now the answer for 122 milligrams left in the body, it'll be after 9.476 hours. So when you are doing these problems, these are really nice things to think about, is I can ask you when, I can ask you what. So there's all types of little things that I could possibly ask you. And then again, you should be able to identify exponential growth and decay. You should be able to identify linear growth and decay. And then you should be able to tell me what the difference is in between a linear and exponential model. So I hope this was helpful, and I look forward to doing yet another one. I think I've got one more up my sleeve. I'm going to do that champagne bottle problem.